Okay, now we're going to talk about slope. It's on the test a lot. You really need to know this. So we're going to focus on this a little more in depth than some of the other subject areas. I want you to pay careful attention. This is going to be on the test. First, we're going to talk about some fun times with the equation of a line. All right, that's what slope is. You see there a skier going down a ski slope. Okay? Slope is represented by the variable m. Slope is the rate of change of the line. So 3 over 1 would be over 3 and up 1, or an increase of 3 inches per year. The equation for slope is m equals y2 minus y1 over x2 minus x1. Okay? So we'll go into the formulas in a second. The first one is the slope-intercept formula of a line. There are two formulas for a line and the slope equation. The slope equation is the one we just did, which is y2 minus y1 over x2 minus x1. And those are the 2 points. So if we have a point that's y2, y1, okay, we look at the bottom point, we subtract that. We look at the other point, we subtract that. Remember, you're subtracting the y values from 2 separate points. Now we have the slope-intercept formula of a line. What this is figuring out the formula of the line. Okay, y equals mx plus b. That's the general formula for a line. Y equals 3x plus 2. What's the slope? What's the intercept? B is the y-intercept. M is the slope. So if we look at a line, and I have the diagram over on the right, the b value, where it intercepts the y-axis, the vertical or the up and down axis, the y-axis, is the b value in that equation. So y equals 3x plus 2, the b value is 2. The slope of the line is the m value. So it's the coefficient here of x, so that's 3. Okay, that's the slope-intercept formula of a line. It's very important. You know this equation. It's very, very important. Next up's the point-slope formula of a line. So here, given a point and coordinates and the slope, you can find the equation of a line. Okay, this is only one point. You could do this with only one point and the slope. So take the slope, m equals 1/2, and the point 6, negative 1. Remember, x comes first, y comes second in coordinates, and you plug it in. Okay, so here's point and slope, where the point is 6, negative 1, slope equals 1/2, y minus y1 equals m, x minus x1, y minus negative 1 equals 1/2 x minus 6, y plus 1 equals 1/2 x minus 3, y plus 1 minus 1 equals 1/2 x minus 3 minus 1, y equals 1/2 x minus 4. Remember, we want to have the standard equation of a line when we finish. So that's the point-slope formula of a line. Very important. Okay? Those 3 formulas, if you're going to remember 3 formulas besides the area of a rectangle, and the formulas with the triangle, these are probably the most important formulas on the exam. Those 2 formula of a line formulas and the formula for slope, which is y2 minus y1 over x2 minus x1. Let's do a reinforcement. What would be the next point on the line passing through these points? I'll give you a moment to pause by pressing space on your keyboard or tapping your mobile device. So what would be the next point on the line passing through these points? Okay? I'll give you a moment. Please do this problem. Okay, I'm back. Now, the next point is 1, 1. You may be confused and thinking it was 2, 2. That's actually wrong. This is a little tricky. We have to use the slope formula, y2 minus y1 over x2 minus x1. Let's plug in. I'm going to take the values for 0 and, I'm going to take the value of 0, 0 and negative 2, negative 2. So that comes out to 0 minus negative 2 divided by 0 minus negative 2 equals 2 divided by 2 equals 1. Now when they say the next point on the line passing through these points, they didn't say there weren't other points that they didn't show. See, that's the trick. Just looking at the graph may lead to error, even though it works sometimes. So a lot of times it really pays to use the slope formula in something like this when you get a question like, what's the next point on the line passing through these points? Okay? This is tricky. If you don't get it, pause it and go back. All right, we're going to do some more slope stuff. Let's talk about perpendicular and parallel slope. Parallel lines have the same slope, m value. Perpendicular line slope is a reciprocal. You flip the fraction. So if the slope of one line was 3, the perpendicular line would have a slope of 1 over 3, since 3 equals 3 over 1, and the reciprocal of that is 1 over 3. If the slope of one line was 5 over 4, what would be the slope of the perpendicular line? How about the parallel line? I'll give you one moment to think about that, and feel free to pause the video. Okay, we're back. If the slope of one line was 5 over 4, what was the slope of the perpendicular line? The parallel line. The parallel line has the same slope, so the parallel line is 5 over 4. The perpendicular line is 4 over 5. We flip it. Okay? So the parallel, you see on the left, those would be two parallel lines. Perpendicular lines would be on your right. So let's talk about some tricky graphs. You have to mind the slope changes in graphs and what they mean. No change is continuous rate of change. Increase, decrease, things like that matter. So if there's no change, it's flat. That doesn't necessarily mean the rate of change, the value is going down. The rate of change just isn't changing. So what that would mean is that's like in a car, if you were going in cruise control 50 miles per hour, the graph would be flat. If you were accelerating, the rate of change, the slope would be increasing. Okay, flat means something stays the same or a pause. So let's look at this graph down here. We have the height and time in seconds. So the height is increasing as time goes on, but then it goes flat. So it's not a rocket ship because they can't stand still in the air. Maybe someone's going up a flight of stairs and resting, or something of that nature, or a car stopped at a stoplight. So it's going, or something's going up in height, and then it's stopping. So maybe I'm going up the stairs. I go up a story, I'm out of breath, I stop, keep going. Or I'm jogging uphill, I stop and keep going. So from, let's say, how many feet are between seconds 2 and 4 in terms of height, or how many meters? How many meters between seconds 2 and 4? 0. You didn't cover any new ground. But they didn't decline in height. It didn't go down. It just stays the same, the exact same height. The rate resumes when the person moves again. So if they start moving again from 4 to 5, the rate increases. Okay, and we have the slope again. So it's moving at the exact same rate as between 1 and 2. Here's another tricky graph. The y value at the start is the starting value. Don't assume it's 0. So say in this graph the starting height would be 100. This indicates something maybe being dropped from a height. If you dropped a bowling ball out a window, the starting height may be 100 meters. I wouldn't recommend that, obviously, because it's a felony. But you drop from 100 meters, and it's going down each time, every second, it's falling. Okay? So it's important to look at these values on graphs and see where they start. If there's a starting value and a declining slope, you may see something like that. Okay, and that's it for this lesson. I'll see you next time.